So let's look at some possible items that could be on test number 4. Ultimately, you should know all of the concepts that we have worked on in the previous practices and in class assignments, and you should know them all well enough to be ready to test on them. I will walk through and kind of give you some guidance, but ultimately, I would learn all the concepts and I would learn all the stuff. However, the test goes from lessons 14A to 18C. So looking through here, we see 14A, the blood pressure and bias. These lessons are heavy on vocabulary. And so if you've not already started some flashcards or a Google Doc or something, that needs to be a priority because you need to know what the words are, how you use them, how you can write about them, when you see them, what they mean, and when you see them, what they don't mean. And so starting here when we're talking about bias, one thing we did in class was we made a dot plot. I would know how to make a dot plot for this test. And anything that doesn't make it to this test could end up on the final. So lots of splotchy words here, but I would know the bold words of sampling error and non-sampling error when it starts to talk about what sampling error is, and then the non-sampling error being the primary source of its primary source is bias. We had somewhere that we talked about the types of bias, and so I'm going to run on next to 14B. And looking here at 14B, it mentions that we have 3 types of bias. I would know these. I'd know them well, how to identify them, and how to write about them. You have non-response, you have response or measurement, and you have selection. Make sure that you know, as I just said, all 3 of these, so that when you have a situation like this where it says what happened in the study, you can either say, hey, it's a good study, or no, it has this type of bias, and then even be able to turn it around where the bias is minimized. Here's another set of words, random selection. Selection is very important on how to select members of studies, how to be random. And then we talked about likely, and this one took some time to chew on during class when we looked up here and saw that we had about over 50% and just over 40% to be a representative sample. And then it mentioned in the study that there would be 500 and 500. Well, that's 50-50. But then here on part F, it says, what if they picked 540 women and 460 men? Well, that represents the 54% and 46%. So really dig in to understand representative sample and tying it into, if it's not a representative sample, then what kind of form or what kind of bias is it illustrating? 14C, the observational studies, and it's the conclusion, yay, of observational studies, lots and lots of words. And they were talking about, and I can't stress enough that when it's observational, you are not allowed to say that it's going to cause anything. And so we spent a lot of time looking at this, that what is our population? What is our sample? Make sure you know how to identify those. And then also make sure that, like on this one, where it talked about 75 local high school students, and then it was going to infer to the United States. You need to be able to, as we've talked about in class and on video, really tear apart a study and really be able to write about it academically. So any of these videos would be great to go back and watch just to let it soak in, let it get in your fingers, put these on flashcards. And then question 5 is really a great one. What are the characteristics of a well-designed statistical study? And so make sure you've got words like minimizing bias, talking about blinding and double blinding, blocking, why we use blocking, how do you assign members to groups, lots of information. Oh, confounding variables, what are they? What happens if we have them? How do we minimize confounding variables? So 15A, the video game diet. We looked at this. We spent a lot of time either in video or in previews and practices talking about Explanatory and response. Make sure you know which one those are, and make sure that you can put them on an XY axis and then talk about them. Just reading through real quickly, talking about the variables. And I'll say again, an observational study is designed to infer to a population. An experimental study is designed to infer to a treatment. Moving on to probably 15A. All things in moderation. We talked a lot about the chocolate. We talked a lot about experiments. Just make sure you're really familiar and feel very comfortable dissecting a study, writing about a study, being able to tell what was done right, what you think should be improved. And then, oh, here's confounding. Make sure you understand what those are and that you can be creative in coming up with confounding variables and how they can impact a study, but also being creative on how to minimize the confounding variables. Placebo. When we're talking about experiments, what's a placebo? What's a placebo effect? Moving on down the page. Yeah, talking about our volunteers, and are volunteers good or bad, or sometimes it's the best we can get. Still looking on through these experiments and observations, the power of the pill. There comes the blinding and the double blind, and placebo effect. When would you use this? When would you not use this? Why would you use these? Lots of good information that we talked about in class. These are all on video. Again, talking about a treatment group and a control group. Which one is which? And then if you're going to do blinding, would you go ahead and do double blinding? And what is that? And there's the double blind. And this is when they were talking about different medications. And then can you really say they're effective? And even if the study's a wash, can you still grab something from it and report out that possibly, or it seems like, or it appears possibly? When we did this experiment on the cold sores, and we talked about blocking, and the bullets and the objectives are very good for getting definitions. Like when it is implemented, it does help minimize variability among the groups. You need to know that. And the reason we do it is, as it says, so that the treatment or the response to a treatment is more obvious. And so we tore apart these studies. We talked about the blocking. Like if we think our treatment or our whatever it is that we're trying to study would have a different effect on different groups, no matter what kind of groups, then it's a very good idea to implement blocking. Make sure you know what that is. Make sure you know when you would use it and how you would comment about it. And like right here, we created some dot plots. I would know how to create a dot plot. In here, we calculated right here, we calculated the mean. Make sure you know how to calculate the mean and to do so really quickly, and to know how to double check yourself and round appropriately and write down all the correct units. So it's like everything we've done all semester is still good. And then we see these final words of in conclusion. And this is the one where we had like a fake placebo, a fake, well, and then we discussed whether we could call it a placebo or not, and whether we could call it even a control and a treatment set of groups. And so go back and look over this study and the things that you wrote in your notes about this study. And even here on this coronary artery risk development, can you identify if it's an observational study or an experimental? Can you write 1 or 2 sentences? You all are turning in 2 paragraphs to me with your self-rating from the rubric. You're getting some great practice on how to write academically using quantitative number, concepts that you know, pull them together, put in your own observation, not opinion, but observation, and really come out with some quality answers. And that's what you need to be prepared to do. So now we're at 16A. I know these stacked column graphs are hard to read, but on the test, I will have them as clear as possible. I will use words like approximate, And I am not my math lab. I will be looking for approximate answers, but you do need to be in the ballpark. You need to be close. So know how to read column graphs, stacked column graphs, and also know how to do not only this kind of chart, but I think there's one more. No, it's not one more. They asked us to add a column to this one where you can calculate absolute change and relative change. I will not have the formulas on the test. You need to come in knowing what they are, how to use them, and how to look at the data and use the data to calculate those numbers. Moving on to B, looking for links. Whenever we did this IQ lesson, we did talk more about the stacked column graphs, and we did talk a little bit more about opinions and noticing items and what is it saying, what is it not saying, and then especially when you get here to number 3, whenever we were talking about which one is not supported by the graph, really understanding parts and wholes of what it's saying. Like, is it talking about the Arizona boys? Like up here, this whole chart were males and females who have or who are on the autism spectrum disorder. And then down here on this question, it says, hey, what it's talking about is 32% of all the boys with intellectual disabilities in Arizona. And it's not true because our chart was only talking about boys and girls, but in this case, boys who were already on the autism spectrum disorder who then had intellectual disabilities. You need to be able to dissect this and know what's the whole, what's the part, and maybe thinking about a circle graph. What would be the whole, what would be the part? So really being able to think critically on this test, having a whole wealth of vocabulary in your brain, a whole wealth of how you've been working the problems well in your homework. And moving on, 16C. Here, it was talking about our study habits. Specifically, it was talking about if you put down some numbers at the first week of class, and then the last, about a week ago, I asked you for some more numbers. And when those were sent in, I included them in our chart. And it was just another way to talk about a stacked column graph, whether we liked how it was presented or not. Again, you need to know how to use a stacked column graph. I'm not going to ask you to create one. I'm going to ask you to take it apart and talk about its numbers. So yes, we had 16D, and on this one it was talking about, scrolling on down, whoops, scrolling back up, Gapminder. So on the test, I can have a picture of one of the screens that we looked at for the gapminder.org. And can you identify the vertical and horizontal axes? Can you talk about what the size of the dot means? Can you talk about the color of the dot? And the test won't be in color, so you can probably guess that can't be on there. But lots of good information, lots of historical pieces, and what were some of the big things that we talked about in class and on the video. We did not do 16E, so you will not see anything on 16E on our test. We did not do anything in 17A. You will, or 16F. So you will not see 16F on our test. We did not do anything on 17A. That will not be on our test. But 17B, the right approach to data, will be. And this is the one where you sent in your 2 paragraphs and your self-rating in the preview. And then when you look at this through our lessons, it's talking about if I'm given data, can I write about it? And that's what we're trying to grow to, is that we can write mathematically. I think the fun thing that we saw when I was in working in my office hour this morning is being able to find a pattern, like describing that blue bar, tell some details about it. And then, oh, if I'm going to talk about the blue bar, talk about the red bar. And if I'm going to talk about it on the 0 to 4, let me find something else that looks interesting to me. One of the students said that, and that was great. She said, well, this looks interesting, then write about it. So can you look at a graph, report on it well, and think about the rubric as you're writing? What are some things you're supposed to do? What are some things like rambling that you're not supposed to do? In lesson 16C, we were talking about lying numbers. Again, you are going to need to be a critical thinker. That means you've been practicing that this whole semester, where you are tearing apart the details, but then reporting academically why you think something is faulty. Like when we talked about these in our lessons, and ultimately here, where we said, hey, we knew all along that they had not reported this using inflation. Now that they have, let's talk about it. Remembering that a pie chart has to add up to 100%, not as this one did not. Can you tear this one apart and report on it critically, like you like the shapes or you don't like the shapes? And then here are the cats, where we were talking about their two pie charts and how they just didn't make sense. Can you report critically on what you're seeing? And here, when it was talking about if we are buying more fruit, we are having fewer burglaries. And can you report out academically that although there is a very strong correlation in this chart, correlation does not imply causation. So you can report out, you can talk about this slope, you can talk about the R squared, you can talk about R, and you can tell and report and say what it is, like the R squared, and use those words like the percent of variance in the, and then you would put the Y variable, and then you would say is determined by or influenced by or because of, and then you put in the X variable. Can you do that? Can you write about what you're seeing? We did do 17D. Can you feel the heat? And this is the one where we were talking about climate and weather, and we looked at scatter plots. And so none of the information here is what I showed in class. The charts are available in the videos, where you again can interpret slope. You can interpret R and R squared, and you can talk about and report out what you see, not only by what's on the graph, but also implement or add in some historical events. We did not do 18A. We did not do 18B, but we did talk about 18B when we were doing lesson 18C. So this modeling cycle, nothing to memorize, but definitely to be familiar with, that you could talk about a situation, a flow chart where I can say, yeah, if we've got a problem, we can formulate some kind of model. We can do some computations, we can look at those, we can say, hey, are these valid? And if they're good, report out, or if they're not good, keep going back in the circle. Let's formulate another thought, let's do some more computations, let's interpret some more. But eventually, we're going to report out, whether it's good, bad, or ugly. We're going to be able to talk about it. We did do lesson 18C. And on lesson 18C, we were talking about the population. We were talking about models. We were talking about what kind of models might best describe our information. And so we were talking here, you need to be familiar with, let me see if they're listed. You need to be familiar with linear, exponential. I'm looking to see if they're listed. There we go. In part B. So once you look at this information, can you calculate an average annual change? Can you calculate an average annual percentage change? And after you calculate it, can you interpret it? Can you say, yes, this is linear, yes, this is exponential or logistic or periodic or something else? Or can you say, wow, this looks like a combination. It's kind of starting out exponential, but then it becomes periodic. But just to be able to know how to calculate the information and then report on it, that's what you'll be expected to do. And that ends this on test number 4. I've covered all of my notes. Study hard. Make sure if you're going to the testing center, you're there in a good amount of time. You check the website before you go. You take the right materials like ID, scientific calculator, and then you just do your very, very best. You work hard for the time frame that you're able to take the test, and watch your time. When I took tests in college, I always I looked at the clock on the wall, or if I had a clock, a wristwatch. Nowadays, it's you can't do that. But look at the clock on the wall and divide up your time. There are about it's 8 or 9 questions on the test. So if it was 8 and you've got an hour, then that means you got to do 2 questions every 15 minutes, and hustle, get it done, skip around. Um, just be a great test taker. Do a data dump before you start your test. That's where you dump all your formulas out of your brain so you're not worried about forgetting them. And then throughout the test, when more stuff comes to mind, go back and add it to your data dump. Lots of great test taking skills, good night's rest, a good meal, hydrated, all of those good things. And definitely a lot of confidence, even if you don't feel confident. Walk in with confidence and definitely do your very, very best. And we'll talk to you more later on another video.